Hello, everyone, and thank you for the nice panel. My question would be going basically to all of you and would raise a question of what high-performance computing for data analysis could mean in your respect. So did you feel limits in the analysis, problems of taking all the data at once and analyze it properly, and what role the computing plays in the process?
Wow, thank God I'm not a scientist. Over to you, Vincent.
From my experience, the problem is not really the computing power, it's more the disk space problem. These images take space, and if you start to acquire a lot of them, you have a lot of space. You need a lot of disk space, so that's mostly this. After, obviously, if you want to analyze through a full stack since the beginning of acquisition, it can take a fair amount of computing power, but we're not talking supercomputer amount yet, I think. But mostly it's important, also if it's for a short-term event, I mean, like when a DAC is propagating, it's a matter of weeks. So you don't need to analyze that much data because there will be maybe like 20, 30 images, so which is reasonable. If you analyze like thousands, I mean, we have to talk a bit. Yeah.
Freysteinn?
Yeah, I can maybe add that most of our volcano models are non-unique. So when we infer that something is happening in the subsurface, it is normally only one model of many possible models, maybe thousands of models. We could very well use supercomputing and high-performance computing facilities to better understand the uncertainties of our findings. And I think that is a very relevant goal for the coming years, actually.
Shay, did you want to comment?
Well, yeah, just in general, I think there's an interesting balance here because when you are talking about kind of unique events or unique research projects, you know, that becomes a bit contained. But then when you talk about scaling a global system, then it's, you know, migrating into the cloud. And so that's an area also that my team at ICEYE works on, like how do we take kind of academic research and then be able to apply it in a way that is persistent and scalable. So it's a very valid point and always a consideration.
Exactly. Okay, next question, please. We have a lady there over in the back, please.
Hi, I was wondering if you could just talk to us a bit about the potential analogs that could be drawn between the Icelandic volcano and Martian volcanism.
Can you repeat the question, please? Between the Icelandic volcano and
Martian volcanism.
Right, okay. So, who would like to take it? Vincent?
Well, we were just talking
Daniel?
about this with Daniel.
Go ahead.
Yeah.
Okay, that's for you.
Well, there have been a number of studies recently that it was thought initially that Mars was volcanically dead. But research recently has been published that shows its potential. Potentially, Mars has been active within the last 500,000 years. And the type of volcanism that has been studied is actually not that dissimilar from the volcanism that's being studied on the Reykjanes Peninsula. And so I think that there are applications, certainly for the work that's been done here. And there's also applications for looking at volcanism on other planets and how to use synthetic aperture radar on other satellites and spacecraft.
Freysteinn?
Yeah, I can add, we have had many planetary scientists coming to Iceland to look for the landforms and study comparison of landforms in Iceland and Mars, including a scientist that was here on a research leave from his post in the US during the eruption. And I think there's a lot to be learned. The radar satellites, they can be used everywhere in the solar system, basically. It's not about only these interferograms or ground deformation where we have gained a lot of knowledge now. It's also about just the precise observations from the basic images that these satellites collect, and high-resolution images, they can help to classify and better understand these landforms. So there is still a potential to learn a lot more from comparison of volcanoes in Iceland and Martian volcanoes. And I think we're just beginning, maybe, even.
Exactly, yes. And we have time for one final question from the audience, please. Yes, please, we have a gentleman there in the middle, please.
Yeah, thank you. Oh, it's loud.
The one on the left, please, go ahead. Unfortunately, time for only one. Go ahead.
Shall I go ahead? Thank you. My name is Hjörleifur Guttormsson. I'm living here in Reykjavik, and I'm watching this volcano from the kitchen in my flat, and but it leads to what shall we expect about continuation of eruptions on the Reykjanes Peninsula in the years to come. Now it has waken up after 8 centuries, and I think it would be interesting to know if we should expect every Arctic Circle to have such a fine eruption. Thank you.
Okay, Vincent, now we'll test your elevator speech. 15 seconds. Go ahead.
I mean, I think, yeah, it could be the beginning of a new rifting episode with a lot of activity in Reykjanes. We have been seeing that if you look at past history, but it's hard to draw. Each system is different from the next one, so it's really hard in volcanology to take one system and apply it to other volcanoes. They're really independent, so it's hard to predict the future still.
Freysteinn, 10 seconds.
We can use coming events on the Reykjanes Peninsula as a natural laboratory if we apply the satellite constellations techniques and combine it with ground deformation and observations on the ground. We have wonderful possibilities to learn more about volcanoes in coming years and decades. I think that is the timescale.